Hello and welcome to Group M20's Project 3 presentation. The topic that we have chosen to detail through research is advances in 3D printed structures and materials. In this report, you will learn about several different ways that existing additive manufacturing processes are being used to create structures. 3D printing itself is a fairly new technology when compared to traditional manufacturing techniques, but the access to technology has allowed this field to grow rapidly in comparison to traditional techniques. In order to talk about how advanced printing of structures is accomplished and what the materials that are being used are, it is important to define how traditional printing is accomplished. A design is made, it's processed into a file format that can be handled by a printer, and it's printed using one of various processes or techniques, such as selective laser sintering or fused deposition modeling. The main constraints of these technologies are that in most cases it is confined to the inside of a relatively small printing machine, which limits the size of what can actually be made. To highlight advances in 3D printing and the materials used in their processes, we looked at 3 examples of where 3D printing is being used to create structures, each with different materials. The first deals with metal structures, the second deals with concrete structures, and the third deals with polymer-based structures. In case 1, we researched a company called MX3D out of Amsterdam. They have been making huge advances in additive manufacturing through the use of advanced robotics with integrated computer controls to operate a steady feed welding machine that continually builds up welds to create 3D load-bearing structures. The major project that MX3D is using to refine their technology is the construction of a bridge that spans a 12-meter gap across a canal in Amsterdam, a section of which is pictured above in the figure. One notable observation is that the geometry of the things that they are able to print is almost organic in form, a departure from traditional I-beam construction. Another case of how metal is being used in new ways in the printing process can be seen in a research paper by Arup Engineering. Arup completed the design and installation of a suspended lighting system over a busy outdoor shopping center. There were numerous cables that were used to hang lighting structures, and therefore it was necessary to build 1,600 cable junctions as pictured for the project, 1,200 of which had slightly different dimensions to accommodate cables at different angles. In their research, Arup investigated how 3D printing could be used to streamline the creation of these 1,200 unique junction points. They found that an additive manufacturing process, in this case selective laser sintering, could be used in order to create these junction points, creating an alternative to welding them out by hand. This also allowed them to depart from traditional geometries, as we've seen in the case with MX3D, dramatically reducing the material needed for components while maintaining structural integrity. Again, the designs themselves lend to a more organic form than what we're accustomed to seeing. The accompanying figure shows a load comparison of the traditional junction point as compared to the proposed 3D printed version, both which are sufficient for the job. What Arup found was that through the use of additive manufacturing, they would be able to create these pieces. However, the cost saved on labor at the time would not offset the high cost of 3D printing, so it was not truly a viable alternative.
In case 2, we focused on the company Apis-Core. In December of 2016, Apis-Core completed the construction of the first on-site 3D printed building. The process is similar to fused deposition modeling. The 38 square meter building was constructed on a test site in the town of Stupino, Moscow. Despite the cold temperatures, the printing process was still able to continue by building a tent around the printer. The whole printing process only took about 24 hours to complete. The 3D printing construction of entire buildings on site is made possible only through Apis-Core's unique construction 3D printer design. The printer is similar to a tower crane, allowing it to execute the printing process of constructing both the inside and outside walls simultaneously. It has an operating range of approximately 132 square meters, and unlike the block printing method, does not require a completely flat surface to start construction. The printer also produces no waste materials. Winsun Global is another company that is making tremendous strides in the field of 3D printing construction. They are pioneers in the industry, holding more than 100 different unique patents. Their most important invention is the first 3D ink and spray nozzle, which is the tool that made 3D printing with materials like cement possible. They also possess the world's largest 3D architecture printer. Winsun has already created several impressive projects, the first being the printing of 10 residential homes in less than 24 hours, and the most recent being the construction of an entire office complex in Dubai. The building process starts with a design made with a CAD system. The design is then uploaded to the printer in the factory, where it begins making walls. The walls are then shipped to the building location, where they are promptly installed and reinforced. Walls are made with a spray nozzle, which adds materials in layers. Layers can be between 0.6 centimeters and 3 centimeters thick. They're made with a special ink comprised of cement, sand, fiber, and a proprietary additive.
Branch Technology is an example of a company that is using a fused deposition modeling type of 3D printing in order to create structures out of polymers. In reality, it is a robotic arm that will be used in the automotive industry on an assembly line that has been fitted with an extruder head. The polymer exits the nozzle as liquid form and quickly solidifies to create the 3D geometry. Structures are created based on computer software guidelines as set in place by the designer. What this software does is instructs the extruder head to take the correct path. Branch Technology is currently developing new ways to use 3D printing on construction sites. One application in which they envision for the future is using 3D printed structures in order to reinforce load-bearing walls. The exterior of the structures are filled with concrete, whereas the interior is filled with expandable foam. The design approach has been discovered to be 1.3 times stronger than a similar section of wall created from the wooden materials. Similarly, this design system allows for construction of buildings with exceptional structural integrity as well as high insulation properties, making them energy efficient. While 3D printing is able to refine traditional manufacturing techniques, Branch Technology is also able to create unique geometries with their technology, such as curves and natural shapes. An example of this is the centerpiece in a pavilion in Miami. In conclusion, we have seen that there have been considerable advancements in the field of 3D printed structures in the past 10 years. Although these advances use common materials, they are doing so in new and unique ways never seen before, allowing things to be printed outside of the box. We project that for the next 5 to 10 years, 3D printing of structures will continue to build momentum. However, given that most of the techniques being used are relatively new, we do not believe that they will be considered as viable alternatives to traditional techniques, with the exception of 3D printing cement structures. 3D printing cement structures is already proving to be cost-effective operations. Apis Core estimates that they could construct a square building with an area of 38 square meters for $223 per square meter, including all exterior and interior furnishings. Winsun's 3D printed office building was also extremely cost-effective. It is estimated that by using Winsun's technology, savings of approximately 80% on construction costs and 60% on labor costs were seen, and overall construction waste was reduced by 60%. Although the process of 3D printing concrete dwellings is still new and there is a learning curve, the potential for companies to save a large portion of cost as well as cut back on waste materials dramatically make it a viable option.